Welcome to to the last day of classes. On 12/12/12. This is CMS.611 or 6073. It's a joint class with 2 course numbers just to make things nice and complicated. Otherwise known as creating video games. I'm Philip Tan. I'm one of the instructors. Other instructors in the audience include Sarah Varelli, Rick Epperhart, and we've had a couple of folks as part of our mentorship team from the MIT Game Lab, including Andrew Grant, Jason Bean, and Abe Stein, who have all helped out with advising these students. We've had, I believe, 34 students in total and 1 dog in the class. And that has been the way how this class has shaped out is the team spent the first 6 weeks or so developing 3 prototypes: a non-digital prototype followed by a digital implementation of that game, a completely new digital prototype created from scratch, and out of that, the teams chose what games they were going to work on for the final project, which took up the second half of the semester. So it was about 6 or 7, what you're going to see is about 6 or 7 weeks of development on top of a couple of rough, sketchy prototypes. Every team is going to have about 25 minutes to present. This includes showing a little bit of gameplay of their game with a little bit of flair. And with that, I'm going to hand it over to the first team. So introduce yourself, and can the audience give them a round of applause, please?
Introductions? Quick introductions. I'm Ben Greenberg. I have been working on this game for the entirety of the time that it's been in development. For this specific game, I did some of the background work and made the instructions page.
I'm Lane Pertuzzi. I'm Lane Pertuzzi. I have also been working on Gavor from the beginning of the semester. In this version, I did the art.
Hi, I'm Kevin White. I've been working on Gavor since the beginning of this project, Project 4, and my job was menu layout and head of buttons.
I'm Todd Layton. I also joined the game on this project. I did primary coding and the backend model and the game logic.
I'm Andres Romero, and I did the networking and odds and ends.
I'm Chris Destinville. I was with this project since the beginning of the semester as well. I'm coach producer with Ben, and I also worked on some of the back-end logic with Todd.
All good? It has been 900 years since the death of our Lord and Savior, Jesus Christ. The world has been thrown into chaos. People are dying every day. Disease is rampant, and men are killing other men. The world has been thrown into utter chaos. But in the midst of this, one form of government has risen up. A royal army has vouched to make the world a safer place to live, has helped the children, has saved the farmers, the peasants that can't defend themselves. The royalist army has been the only light in the darkness. But, like every government, the rebels have risen up. They seek to take power for themselves, to destroy the royal army. They will stop at nothing to fertilize the fields with blood. Please rise, Sir Justin Wallace, Commander-in-Chief of the rebel scum. And please rise, Sir Jacob Masterson, Commander-in-Chief of the Royal Army. Today is the first battle. They have met on a field to claim glory for their respective armies. To battle. Oh, the rebels are making a quick charge. Infantry units are able to move 2 spots in one go. Oh, the speed of the cavalry is unparalleled. Looks like he's going straight for the front lines, moving the archers into formation. Infantry units are the only ones able to cross the swamps. The rebels might use that to their advantage. The royalists don't want to be shown up. They're going right out there to meet fire with fire. Oh, a big jump by the cavalry there. That could come back to bite him. Moving into formation. They're all just setting up right now, waiting for a strike. Oh, and the rebels have made the first attack. It is successful. The infantry is down. Interesting strategy. Going around for the cavalry. Can he strike the death blow here? Oh. Normally a unit will have 1 in 6 chance of making a critical attack, but from behind, it's all but guaranteed. Looks like the archers are moving in. Oh, the rebels look strong. Oh, a powerful attack there. Got him from behind. The archers set up an attack. Critical. The first infantry unit has been destroyed. The rebels are being taken. Solid attack. The royalists are looking powerful. How will the rebels counter? Oh, going in from behind. Sneaky. Ooh, that was big. Oh, the rebels can't use the swamps. This is hurting them. Their movement is... Oh, what's he doing? Oh. You must now know that the adrenaline is pumping. Both sides just want to win. They can't risk anything, and yet they have to give it all. They know that they won't be taking it easy on. Oh, an archer unit destroyed. The royalists look powerful. Can they be stopped? Ooh. Any attack is a 1 in 6 chance of being blocked. That was just pure unlucky. Oh, he destroyed him! That was an unnecessary critical attack, but you'll always take it. Oh, wow. I don't even know who's winning this one. It looks perfectly even. Ladies and gentlemen, this is quite a finale. Oh, the rebels move in for the kill. This could be the end. Oh, a successful attack. Oh, critical. This battle looks so... This battle's ending fast. They're just running circles around each other now. And a strike. Back attack. Oh, the Royalists look outnumbered. Could this be the battle? Oh! And in a marvelous turn of events, the Royalists have been defeated, and the world will be thrown into chaos. Shall he be allowed to live, or should he die? Awesome, thank you. Yeah, is it open or no? Okay, so the project that we worked on for this was Gavor 2, the Ungaveling of Ambidextria. As we explained before, we've been working on this project for pretty much the entire semester. Myself, Lynn, and Chris were actually on the team from the very beginning. The second day of class, we started working on it and beginning with the design. So where did it come from? The first original idea that we had was actually a turn-based tower defense game, where it would be kind of like Go, and each team would place towers on this map that would then attack each other throughout the game, and it would use strategy, various methods. So I came into class with all these ideas on how I would figure that out and orient that, how we were going to paper prototype it. And Lane came in with an idea that was kind of completely different than anything I thought that we were discussing at the time, which was for a way to simulate medieval warfare on a board. So he said that he didn't think that games like chess gave the pieces enough movement and gave the players enough freedom. So he wanted to use a hex board because he hadn't really seen anything quite like this done on a hex board before. So this was the original design. That was our original hex board with these little furry animal rubber creatures. We originally made this massive hex board, had to scale back tremendously. The first game took like 45 minutes to get through or something like that. So we scaled back, but the basic design and principles are actually the same that they were on day one, which is kind of incredible. We really didn't change the whole concept of the game that much because it was a great idea straight from the beginning. And came the birth of Gavor. So the second project, for those of you that don't know, was to take this original prototype that we made and turn it into a virtual version. This is where we picked up Calvin on the team, and this is a screenshot from the second iteration. This was where we came in with the idea of using the number of images in order to show a unit's health. This was where we started laying out different designs for the hex board, started thinking of various ways to orient it, and I thought we actually had a very successful second iteration. Went through the whole thing, development and everything. Then we had to come to the fourth project. Third project, we went off on something else. But the fourth project had to take what we had made, polish it, and make it better. And we had tons of ideas. I just wanted to take the original and make it more. I wanted better graphics, more units, terrain, different gameplay, networking, AI. It went absolutely crazy. The screen's all cluttered. You can see with all our different ideas. We were basically trying to make StarCraft. And that just wasn't going to happen. So we needed to take everything into perspective and see what really was the meat and potatoes of the game, what we needed to have done, what had to happen, and what was kind of would be nice but not 100% necessary. So we made a plan. Chris was the main organizational producer for the game. He was incredibly well organized. I was far and away impressed with how he organized a team of 8 people. Everyone got everything done on time. There were emails sent out. Everything seemed to work very well. So he made this 6-week plan. He said that the first 2 weeks we would be trying to recreate Gavor 1, basically, that first game that you saw on the screen. That was written in Python. We wanted to recreate it in Java in 2 weeks. So we started working on that. He also said that after we got that done, we'd start working on some more advanced things. Maybe put in some terrain, put in some AI, whatever we deemed was fit and would make the game more fun, better to play for the entire audience and everything. We also had a mini game in the game originally. That was one of our big key concepts. That was going to come in 3rd, 4th week. And then the last 2 weeks were going to be used specifically for polish. So basically, we had time to correct any bugs in the game, make anything that needed to be fixed and tweaked happen. So the first 2 weeks happened, and everything seemed to be going great. We got a working prototype that looked and played very similar to the original Gavor within 2 weeks. Everything seemed to be up to scale. 3 weeks passed. We had a simple mini game going, started working in terrain. Everything seemed to be going to plan, except that the mini game wasn't fun. In all my playtests, I had one playtester ever tell me that they really enjoyed the mini game and thought it added something huge to the game that they really wanted. And that was only because of the luck aspect, which we wound up keeping in anyway. So we were making a bunch of different tweaks to it, and about a week ago, we decided, you know what? We're trying so hard to make this mini game that no one really likes. It's fun, so we cut it out of the game entirely. That was our biggest scale back. There were some other things also. We took out AI because that was just unrealistic on the time scale that we had. But we did keep in a ton of other stuff. OK, so going back to the mini game. What happened was, whenever you would start up a game, whenever you would attack a piece, you would be launched into this basically completely other world that had absolutely nothing to do with the game. It was a rock, paper, scissors layout. Because of networking, we couldn't have something more complicated than that. You would have to use the keyboard. This was the only time in the game that you actually used the keyboard. So people were getting confused by that. You had to react quickly because we didn't want the minigame to take too long and lengthen the game by 20 minutes. And it was incredibly confusing for the players. No one really knew what to do. It was really just luck anyway. We originally thought that, kind of like when you go to play someone rock, paper, scissors, shoot, you always have your strategy before you go. You go, scissors, oh, I thought he was going to do rock, whatever. You always have a way to go into rock, paper, scissors, shoot. You always think you're going to win. And we thought that this would be like that. It wasn't at all. People immediately realized that it was completely luck-based. Just pressed a random button as quickly as they could and hoped for the best. So now looking back, we spent so long developing this project, so long tweaking everything, polishing it, learning absolutely everything that there was to do with it. So if I had to change something out of it, this is what I would kind of take away. I would have done earlier playtesting on this final project. I thought that because we had a ready-to-developed game that was fun to play and I had gotten great feedback on, that we could delay playtesting until we had something really completely original. And that was a mistake. Again, we took out the minigame way too late. There were just a lot of feedback that I could have gotten on the actual gameplay, on the control scheme itself, that would have been very helpful earlier on. A paper prototype. So we used a paper prototype for the original 2 weeks, cut that, went into a virtual prototype, had that going. Then we started making this game. From the time that we started this game, we never actually went back to a paper prototype. And there were some things, like you saw that the infantry were the highest health unit. That was just put in 3 or 4 days ago because we decided that we really wanted a tank unit, and the infantry could kind of do that. They could be charge in, set up your formation, take a lot of hits and not die. But we never had a real chance to test that in gameplay because we didn't use paper prototyping. If I had just taken a hex board, put it on the table, and played a game with someone where I can declare whatever health I want because all units are represented by pennies or something, that would have been very simple and easy to do quickly. The third thing that we really needed to do was play around with constants. Except for the infantry health, just about everything you saw was the same values that we created in the original game. A lot of things Todd kept saying throughout, guys, I just chose some random number that seemed like it would make sense. We should try and tweak this, try and play with it, see what works better, see what people like. And a lot of that didn't happen until at the end of the project, where it could have, if it had happened earlier, if we had done little detail stuff like that earlier, it could have maybe shown us some other thing that people were having issues with, as opposed to, well, I really don't like that cavalry can move 2 squares, which is the same range that archers can shoot. Like, that was just some randomly, arbitrarily chosen number. And if that's what people were complaining about, we could fix that in 2 seconds, as opposed to the control scheme not being completely natural, which they might have thought was more minor, but is actually a much bigger deal to change. And one thing that I was very impressed about this game was that our organization was incredible. I cannot get over how everything that we needed to get done was done immediately. If someone sent out an issue, oh, there's this bug in the game, 4 people would say, OK, I'm working on it. And even if it couldn't be resolved quickly because it was something a little major, they would we had immediate response. No 2 people were really working on the same feature simultaneously, trying to implement the same thing twice, which would cause collisions, wasted work hours. We really did a great job of telling each other what we were going to do, assigning it on GitHub, making sure everything was documented and everyone knew what was going on at all times. I was always aware of what Calvin and Lane and whatever everyone was doing at all times. So I really felt like that was one of the biggest pluses that we had from this project, and one of the reasons I thought this team was so great to work with. And that is Gavor 2, the Engaveling of the land of ambidextria. Do we have any questions, or what are we doing? Oh.
We'd have time, I think, for let's have the next team set up the computers while we take a couple of questions from the audience. So if there's any questions, please put up your hands. I'll walk over with the mic. I see a question all the way in the back.
I'm curious where the name came from, especially the reference to ambidextrous when I didn't see it in the gameplay.
OK. Gavor was completely my own original idea. Kind of pulled it out of a hat. It made sense to the game. I don't know. Sounded fantasy-ish. Ambidextria is because all the art axes, whether you realized it or not, are mirror images. When they're facing one way, they're mirror images of when they're facing the other way. And so they can wield their weapons in both their left and right hand. Yep.
Is this going to be the setup for a future Gavor franchise?
I keep saying that I want to make it RTS. Some people have issues with that. They think it'll be a bit too big. But I had huge ideas going into this project, and I have not given up on them yet. All good?
OK.
Nice.
All right. Thank you very much.
So, hello everybody. We are the Psycho Bunnies team. My name is David Chow, and everybody here is Predrag Gorowski, Kevin Yu, Turner Bolin, Zach Sigel's kind of behind there, Evan Davis, Eli Davis, I'm sorry, Ziad Baklini, and Patrick Turner. So, wait. Patrick Hulen, I'm sorry. Yeah, okay. So, in terms of our game, we knew from the get-go that we had 3 things that we wanted to do. 2 of them were given us from the project from the get-go. The first one being we wanted to be cooperative play, 2-player. The 2-player was handed us from the beginning. The cooperative was we wanted that feeling of everybody working together for a common objective. We also wanted it to be not only fun to play, but also to watch. And that was one of the things we wanted to do for this project. Everybody actually had to do it for this project. But the thing is, when it's an audience that needs to have fun as well, that's a very different set of requirements than having the players who are actively touching keys. It's very, very different trying to make that work as well. And the final thing is we wanted a unique platformer mechanic. And we had previously thought of something, and we had this from the previous prototype, which involved remapping player controls. And while that was a lot of fun to watch, it turned out for players it was too confusing, and there were a lot of rough edges with the game code as well. So going to this project, we decided let's scrap a lot of this and preserve a lot of the core mechanics. We still want the bunnies, we still want a unique mechanic, but let's try doing something different. So in order to do this, we decided to split development into 3 stages. The first one was going to be the game engine. We didn't know what we wanted in terms of mechanics, but we knew that we wanted a game engine that could handle whatever we threw at it. So the first stage, we really would focus on making a stable game engine. It would run, and anything we put on it would work. The second stage is once we got that one running, we would start prototyping all the mechanics we thought up in parallel. So maybe one two-person team's going to work on a slingshot mechanic. Maybe someone's going to work on trying to make control remapping work better. Maybe one person wants to try 3 different tile mechanics. And this was the time where we really tried those and see what stuck. Once we figured that out, we then moved into, OK, we have these mechanics. These work really, really well. Let's figure out how we want the game to look such that it really focuses on these mechanics and brings them out and integrates them all together. And so that was working on the theme and iterating so that we know that by the time we have a finished game, everything works together. And so coordinating these 3 stages actually is a kind of an interesting problem. What we ended up doing for that is we make sure we spend around half an hour every class just as a team coordinating, figuring out what we liked, what we didn't like. And some of our best ideas came out of that space, not just coordination, but half of our mechanics, I think, actually came out of that. And when we needed to, we would swap roles depending on what was the most pressing thing for the week. If we have a game collision engine that's really has a lot of bugs, we might pull someone in from the assets team and have them work on everything, on other parts of programming, while the other programmers really focus on getting those bugs squashed. On the side, once we were outside of the classroom, we wanted to make sure that we had a central mailing list so that everything could go. We had version control, bug and feature tracking, so that at any given moment, everybody knew what was the most important thing, what they were doing, and where everybody else was as well. And this seemed to work really, really well. I personally really, really like this game. I think I say that's true for everybody else on the team as well. So without further ado, let's do a demo. So we have 2 people, I believe. Yes, there we go.
Just want to introduce our playtesters. This is Sam and Hunji. They both volunteered to help us out with this, so enjoy. And as a side note, their hats are going to match the bunnies they're playing on screen, so you should be able to follow everything.
Oh, I'm sorry. You need to come here.
No, I'm getting there.
Yay! Oh, sorry. Wait.
No, wait. I need to be pulled up.
Oh no. Wait. Yeah. Oh no.
Wait, no, pull me up.
Okay.
But I still need to.
Oh. That's what I'm sorry. Okay, I jump first. No, I guess not. Oh no. Yay.
Oh, wait.
Okay, ready? Yay! Oh. No! Me first! Oh no! Oh. Oh. No! Wait, come get me. Hurry. Wait. No. That was unintentional. I'll come get you. No, never mind. Wait. Okay. Wait, let me move over. Finally! Yeah!
Okay. Thanks to our wonderful playtesters. I hope you guys enjoyed the game. So, for a game so heavily focused on physics performing well, we had to make sure that we had a physics engine that could go very well with it. And in that regard, we had 3 key factors that we had to pay attention to in order to make this succeed. First of all, we wanted to have a physics engine that could deliver 60 frames a second no matter what is going on the screen on normal everyday hardware. This is because we wanted motion in the game to appear fluid instead of like a choppy slideshow. The second thing is we wanted it to behave realistically and intuitively, exactly as the player would expect. Otherwise, players would get frustrated when the bunny ends up in the wrong place, and it would take them a moment to get their bearings back, and they might very well die, as you just noticed in the playthrough. The third point was we had to make the engine be very, very easily extendable. David in his talk mentioned that we actually created the engine before we had a very clear picture of what our game was going to end up being. So that meant that we had to make it a very general purpose engine. We had to make sure that all the different tile types were treated as black boxes so that any person on our design team could, in 5 or 10 or 15 lines of code, add a new tile that did exactly what they wanted without fearing that the engine would break or that it would need to be recoded from scratch. So it was a very, very difficult decision to make, but in the end we decided to write our own physics engine in order to make sure that we can accommodate all 3 of these goals and also keep up with any new features that came up and also with any potential bugs that might come up as a result of playtesting, and we playtested this a lot. So we decided to go for the simplest thing that could possibly work. As you all know, game time is not continuous, it is in fact discrete and happens in ticks. One tick is approximately 15 to 20 milliseconds long. So in that regard, we decided to take, for each tick, the physical state of all objects on the screen. And in this particular example, you can see that this bunny is in the bottom left compared to these 2 pillars and moving with an upwards and to the right velocity. So at that state, nothing is colliding. Clearly, all hitboxes are disjoint. There are no problems. So next tick happens. All the values are updated by 15 milliseconds or however long the tick was. The bunny is on the other side of the pillar, and there are still no collisions. The bunny continues on its original trajectory. What is wrong with this picture? The bunny actually hit a pillar. You can see the red circle here. So while this worked very well for the engine, right? The engine had sustained 60 frames per second. It was highly unintuitive. Your bunny just teleported through an object. And that is not what we wanted. In addition, this iteration of the physics engine actually took its role as general purpose a bit too seriously. It was checking each and every object on the screen. It was checking it for collisions against every other object on the screen. Now this is very easy to code, but not necessarily a very good idea, because you end up checking a lot of terrain tiles that never move against other terrain tiles that never move, which can never have collisions. So we decided for the second iteration to take this out. We decided to not check for collisions any objects that we could guarantee would never collide. So this includes terrain against terrain. It also includes checking the bunny for collisions when the bunny is here with terrain that is over here on the map. They're clearly in two different locations, so they have not collided. With the resulting increase in performance from the engine, we could, first of all, support bigger levels, and second of all, have shorter tick durations so that we could scan more intermediate states. So to move back to the original example, instead of scanning to this state, we would instead scan an intermediate state where the bunny is colliding against the top pillar, and therefore we would say the bunny collided with the pillar, its vertical velocity is now 0, and the bunny moves to the right. However, there's still something wrong with this picture. What happened was the bunny actually hit the bottom pillar, and a resolution with her tick scanning is not big enough to determine that. So even though the bunny's collision with the top pillar was successfully resolved, it was not what the player should expect. The bunny actually passed right through the bottom pillar. So what we ended up doing is the final version of this project is we decided to take the state of all objects before the tick and the state after the tick and calculate the trajectories of every single object moving on the screen and check those for collisions with some fancy math. So what we ended up doing is we could determine with absolute certainty that this collision would occur first, that the bunny hit the bottom pillar with its right side, therefore its horizontal velocity should get canceled and the bunny should move straight up. This is the final version of our physics engine. This is what you saw in the game in action earlier, and I'm happy to say that on our technically most challenging level, we are pushing over 100 frames per second.
Hi, so I'm here to talk for the design team, and I'll have a moral of the story. I'll get to that in a little bit. But for those of you who are in the class, y'all know that Philip Tan, our professor, has a favorite word, and that favorite word is playtesting. So at the beginning of this class, I was taking a look, and we were thinking about this, and we said, you know what the heck, he's a professor. He probably knows something about what he's talking about. So let's do this. And it actually worked amazingly well. One of the things that I'm most proud about our game is the fact that I'm perfectly happy to make the claim that we have tried more things than anyone else. And I'm going to explain how we did that. So our big innovation is, somebody's probably done it before, but I'd like to credit us with it. Our big innovation is the parallel design. So what we did is, at the beginning, we had our design team, and we told them basically split up. Each of you is your own design team. What we're going to do is we're going to have each of you develop the ideas that you find interesting. First, the mechanics that you find interesting, and then the levels, and then the special tiles, and so on and so forth, on your own. And then we're going to meet back up here in a week or 2 weeks, and we're going to see how it turned out. And this was really useful because it allowed us to test effectively 3 times as many things at once. It doesn't matter how bad your ideas are sometimes, because some percentage of them will have something good in them, even if you're just shotgunning ideas, which is exactly what we decided to do. The main reason that this ended up working well is because we linked it very, very tightly to playtesting and kept it under control. So not only did we say you have to think of a new design that worked really well, you actually had to build it, and you had to get people to play it, and you had to get people to agree it was good. And this is why, for our project, we could do so many things with the design, because at any point in time, we would have 4 or 5 designs running, and we would know exactly how good each one was, because we had people telling us, I don't like this. So the example of this is the tutorial map, which everybody who has played our game has played through. So the original concept for this was just a big square where you could fling yourself around and not have to worry about dying, and therefore learn the mechanics of slingshotting. But the problem with this is it's boring, and so we decided to move away from that and actually give people some direction. So this is a screenshot of the first tutorial map that we built. It looks somewhat similar on the surface level to the later tutorials. However, as you'll notice, we just kind of threw 2 bunnies on a screen, and it's basically a level in and of itself. You can die if you go off the left side. You notice in the top left of the screen there's a hole, and you'll still die if you fly off of it. There's not really too much that would let the player really get used to this game, aside from maybe they'll play this through 150,000 times and get so good at every type of thing that they can do it in their sleep. But that's boring, and we wanted to make a game. So our next idea was that we would then write help text for everyone. But this is a screen of text and looks like a pizza, and nobody wants to do that. So after this idea, we got some feedback saying that this was bad. Nobody really wanted to read this much stuff. So again, our design team took it back, and we went to talk to our programmers, and our programmers came up with this elegant solution where the text would only be displayed if you were standing in the place where it was relevant. So now you only have to read one sentence instead of an entire page full of text. Do you know what the problem with this is? Nobody reads the sentence. I'm serious. So we eventually revamped the level. This is with the new artwork now because we've progressed past the original artwork. And we put signs. We were like, okay, so you go this way, you make these jumps. But the problem with this is it's still not a great tutorial because it doesn't tell you how to do it. It just tells you where to go. And people may be able to figure that out already. So after receiving so much feedback from people, now we're on the 5th design iteration. We were just like, forget this. Nobody reads our text anyways. People will look at things. For example, in this one, you'll notice the text in the middle near the top. It says slingshots work in midair, jump to aim it properly. Nobody read that. Nobody ever tried to jump to get up that ledge. So we just finally decided, forget it. We will do the simplest thing we can possibly do, which is draw a picture. It's not drawn in crayon, but it's as close as we could get, and it shows exactly what you have to do to go from one place to another. And actually, surprisingly, I think that this is something that has worked spectacularly for our game. The fact that we were capable of doing things like this and willing to do things like this meant that we could basically give players step-by-step instructions while never breaking them out of the game they were playing. The text is displayed, but actually, to be honest, I don't think anyone reads the text now anymore anyways, and I don't think they're supposed to.
All right, so last but definitely not least is the theming, the story, polish, all those art bits that have been showing up this whole time, and hopefully you've appreciated. So our theme, we had this weird issue when we first started working off the prototype, which is we had these adorable little bunnies, and they're jumping around, they're having a great time, they're making cute little yippee noises, and then they die all the time, over and over and over, and what do? Like, you can't have this, or at least we didn't think it made that much sense to have these adorable bunnies in this adorable scene and then death all the time. So we said, okay, instead of trying to fix this and make our game cutesy or make our game really dark, let's just embrace the contradiction and run with it. So you saw hints of this, and I'll get to more of this in polish, but we went with that, and our story is super straightforward. You saw it in our instant prologue, which, by the way, was put together in a matter of hours, I think, as a set of polish. That was a lot of the kind of corner cutting we made to get things in on time in 6 or 7 weeks. So our story is, you're this cute little blue bunny. Here you are with your mom in your cage. You know, you're very happy, having a fine life. And then this lab assistant, I swear it wasn't me, comes and takes you out of your cage and starts experimenting with you. And they're pouring chemicals on you, and they're bouncing you off purple bouncy goo, and who knows what it is. And if you actually read the text in the game, it turns out it's really incompatible with bunny fur, and they actually had to shave their subjects. It was very sad. And so you decide, well, enough of this. I'm going to escape. And that's where we leave you. That is your game. Given a lot more time, that will be expanded upon until it's much more integrated with the game. But even without that time, we decided that the theme had to be the unifying factor in this game. We had to make sure that that theme, as you walked through this, carried you through the game, gave you a reason to play the additional levels. Nothing seemed out of place. So that's actually a lot of what we put our polish time into. We spent most of the last, I would say, 11 days, 10 days, just adding in things that we saw that would make this more cohesive. One of the big things is this win screen. This is the win screen after every level. Here's some example text on it. You can read the bottom part. It says, Polymer 730X and bunny fur highly incompatible. Consider shaving subjects. This is all through our game. If you noticed, the eyes in the actual thing actually follow your cursor. It's kind of creepy. That was totally going for that. I think it worked really well. We added a whole lot of other things like that in order to make this clear. I can't open my list because of my gloves, but trust me, they were great. And the second part of that was intuitiveness. It had to be incredibly intuitive to play, like we were saying with the graphics game, or the graphics engine. And one of the biggest things was actually just changing the graphic that we used for the slingshot. It's super simple. It took a bunch of brainstorming to get the right one. But you can see on your left here, the hand that we originally had, it was supposed to be like, you know, your psychic ability to pull your friend up. And the thing is, everyone looked at that and went, oh, it's an elastic band. If I go farther away, it'll pull harder. That's not how the game works, and it ended up completely ruining the experience for the first level for a lot of people. And as another thing that was said in class over and over and over is that you have to win someone in the first 30 seconds. They're not going to play your game. Even that is a lot, 10 seconds. They have to play the first 10 seconds and love it. So we changed it, and this next graphic totally fixed it. No one has that intuition problem anymore. They play the game. It doesn't look like an elastic because they're not connected. They get the idea. They're good to go. So lots of times in Polish, would totally recommend doing the same thing. I think we did that very well, play testing throughout the whole time, and came up with a really good final product. So you can email us if you want to know more about this. I think a bunch of us are going to continue development on it. And questions? Oh, and actually, we have 5 more minutes, so we might do another level or 2 with our advanced players. In other words, so yeah, you guys can ask questions while they play. Another thing I want to mention, Kevin was joking around about playing a level 150,000 times. He can beat our entire game from start to finish, single-handed, without a partner. He's playing both bunnies at once in 17 minutes. He has played this so many times. It's really impressive, but here's some of our other expert players.
So we designed our level select screen in order to make it impossible for you to get to a level unless you could actually, you know, get to the level.
All right. It stops you from playing the insane level on the first try.
Do you want to try this way? Ready? Go.
Okay.
Okay, cool. All right, are you slinging me over there?
Oh, oops.
All right, whatever.
Oh.
Wait, dude.
No, I'll go.
Okay.
Okay, there we go. Okay, get me. Yeah. Okay. Okay.
Yes. All right.
Okay, let's go. Okay, here we go.
Wait.
No, are we going up or are we going down?
Just go this way.
Okay. Okay, come up here. Come on, let's go.
Oh, sweet.
Okay.
No, we don't need to be up there.
No.
All right.
Okay. We're good.
All right, fling me up.
For real this time.
Okay. Oh, no.
Okay.
What
are we doing?
Just go down.
Okay.
I'm gonna. Okay.
Yes, throw me. Okay. Okay, we got this.
Alright,
Yeah, okay.
Alright, give me
up. Okay.
Sweet.
Okay. Let's do that.
Do you have time for another?
Yeah, let's do that.
We did that way faster than we usually do. Alright.
Free fall, definitely.
Okay, yep. What are you doing? Alright, ready? Okay.
No, that was your fault.
Yeah,
okay, that was
my fault,
100% your fault.
Okay, ready? Alright, go. Oh, we got this. Yeah. Are we doing free fall?
Yeah, let's do free fall. Okay.
Okay, yep, you went first, so we're going.
You're coming with me, like it or not.
Alright, stay up there, because you're gonna die if you go down here.
No, I can get you. Okay, just wait for that thing. Okay.
Alright,
okay.
Go.
Okay. Can you get up here?
Do we want to, though? No, I'm gonna stay down here.
No.
Okay.
What? Okay, that was your fault.
Alright, let's go.
No.
I'm just gonna stay down here, man. Safe.
No, well, up here is more fun.
Dude, it's like so safe down here.
Yeah, but safety is really overrated.
There's candy.
What's being a bunny without a little breath with death every now and then?
See, man?
You can see the attitude
we had
of
the overhead.
the guys designing this game and why it turned out like it did.
Did you just die again?
Yeah,
Just
that was
come
my
down here
fault.
with me.
No.
Alright. Fine, do you want to go down here? It's like... Oh, that was me.
Okay, I'll go down here.
Alright, I'm going to go up, though, because I don't want to share blocks with you.
That's not very cooperative.
Because you have cookies then. Okay, yep.
Okay, that was your fault.
That was my fault. Alright, we're just
While
getting
they're
on top.
trying, if you guys do have any questions, feel free to ask away, and we'll take it in the last 2 minutes.
No, wait. Okay.
Okay, let's go.
Yeah, just
Okay, we got this.
Okay,
Okay. Okay. Okay, we got this. We got this.
Just like rush.
Okay, let's go. Go, 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 go. Oh my God, there's a spike at the end. What'd you do? That was my fault.
Okay,
that was my fault.
This
I
is
admit.
fine. You
I
can
admit.
just walk, man.
Oh yeah. Okay. Oh my God, there's so many.
Just all right, ready?
Okay.
Go.
Okay. Okay. We got this. Woo. Yeah. Okay. Yeah.
I want to ask about the collision detection system. So you have a predictive model for figuring out exactly where the bunny's gonna go, or like make the right decision for that collision. How long did it take to code that scheme?
Good question. So the version 1.0 that I mentioned came in along with everything else for the first prototype in about 2 weeks. The 2.0 version was probably about a week and a half of more work. And then iteration 3 was basically all of Thanksgiving for David and me.
In general, the collision engine lasted for each version lasted about as long as we could keep fixing bugs and have it still work. As soon as we found a bug for which whatever strategy we're using was just not going to work, we switched to the new one. So each engine actually took maybe a couple days of dedicated work to get done. It was really just fixing small case, small case, small case, small case. We really couldn't even expect because we hadn't even implemented the mechanics until then.
So actually, the way we were transitioning from engine to engine is also very interesting, because what we ended up doing is we would have both collision engines running on the same data simultaneously, and we would then diff the outputs of the two. So we wanted to see how and why they were being different, and make sure it was either a bug in the old engine or a bug in the new engine that we needed to fix. So in that regard, I think that it was a pretty fluent transition, and it worked out really well in the end.
I'm just curious if you guys are going to release this game sometimes.
We've been thinking about it. Some of us definitely want to at least polish up some of the things that we haven't had time to finish yet. We had a great many good design ideas, which just simply because of the scope of the class we couldn't get to in 6 weeks. But given maybe a little bit extra time, we'll have it. Currently, it's probably free to download somewhere, if you know where to look.
It's on our GitHub. We can also give you access to our team mailing list, so you can email us and we'll send you a copy. Yeah, okay, it's on the slide. It was on the slide.
Psychobunnies at mit.edu.
Thanks.
Okay, so we are team Magic Mecha Bear Puncher 9000, and yeah, is that awesome? And here we are. So I am Law Smith. I was the project manager, and I'm just going to introduce our team. So we have Mike Salvato, and over here we have Daniel Hines. I think you have to like walk in as I introduce you. So this is Daniel Hines, Beth Finley. You have to walk in. Nolan Easton, Wei Wei Liu, Steven Zhang. We're a shy bunch, and David Bosek. And the general idea is a side-scrolling beat 'em up where you are a hero on his way to just beat as many enemies as possible. And I'm not going to say much about it. I'm just going to let our wonderful our players just play it for you. And without further ado.
Mike, do you want to introduce them?
Oh, yeah, sorry.
Sure. Our two lovely playtesters are Sergi and Tiffany.
Whoa, what the hell? What? What? No, I'm on fire.
Wait, what? Are you okay there, Sergi?
I was just on fire. It was fine. Hey. Oh, shit. Hey, don't punch me. Oh, I missed the one. Ooh, this is fun.
Ooh, night scene.
No, what? No, don't. Don't punch me. No,
Wait,
no.
wait, oh my god,
No.
I'm a bear.
I want to be a bear. Oh, oh. Oh, yeah. Ah. Oh. I'm so dead. Man, these guys suck. What the hell? Oh, I see.
Wait, what are you?
I'm just underground. Oh, I couldn't attack any enemies with that. Oh no! Oh no! Oh, what? I need the shovel. Die!
Oh my god, I'm like a Diglett or something.
Yeah, exactly like a Diglett.
Oh my god.
Just kill him. Punch. There's so many of them. No. He's getting. Oh no, I'm dead. Oh no, I want to die. Ow. Yay. Ah.
Thank you. You guys as well.
I have to hit her. I can move over here.
Okay. Turn it off? Huh? What's going? Oh, okay. Give it just a sec. That's a good question.
Just a sec.
It said play. I don't want to play.
Okay. Hey guys, so we're Magic Mecha Bear Puncher 9000. I'm going to talk a bit about how our game changed from the start and how we ended up with what we have now. So our initial name was How to Save the World in 5 Minutes. That was a Project 3 game. It basically involved running around. You kind of dodged a plot of like an RPG, and you hit the plot, and that started side quests that were little mini games that slowed you down from completing the plot. It was a little weird. Players liked the mini games, but the mini games were actually what slowed you down from completing the game, and it was really confusing because the most fun part of the game was not actually what your goal was. So we were like, okay, well, let's take the RPG aspect, but build it around mini games. And that was where we started with How to Save the World in 15 minutes. You were going to move through kind of towns, forests, look kind of like Pokemon or Legend of Zelda, and you did little RPGs, like, oh, you help people out, you help townspeople do things, you maybe fight monsters. It all happened in little mini games. Okay, so when we actually got to playing this in class, we had our whole first hub set up, which was a town. You could run around, you could go to a shop, you could talk to an old man who gave you this lecture about the town and how you should be an adventurer and stuff. You could go to an inn. You know, it was kind of an RPG world, but you know, we'd hoped that the mini games would be really funny and players would play them and be like, oh, haha, like this is a parody of an RPG. It's funny, but it wasn't so much. Also, our whole idea of how the players would interact would be in between the different hubs. Like as they move from forest to town, or as they move from town to forest, they'd go together, maybe go through some stage together. But for the rest of it, they were kind of moving through the town separately, and they didn't interact very much. And that meant that it wasn't very fun to watch. We've kind of learned to have the players need to be kind of doing vaguely the same thing. And in this version, they were not. They were just completely on their own. It wasn't very fun to watch. So, halfway through the project or so, we were like, okay, we need to completely change our game. We thought that the transition levels where they're going to move around together, those were going to be the kind of fun part of the game. They'd run around, you know, they'd maybe hit stuff. So why don't we just base our whole game on that? So they were going to have the most action, but you know, we didn't have that yet. So the game, our new model, became kind of a brawler, beat 'em up game where, you know, the players run around. They can punch things. They can pick up new weapons, which let them do special. They give them special abilities, and they basically fight lots of monsters as they fight through different stages and get to the end. So this was pretty cool. We knew that since we didn't have much time, we couldn't go crazy with scope. We needed to scale it down, make sure that we didn't like just try and make a ton of enemies, a ton of weapons. We were like, okay, what'll be the best things that we can do? We'll put those in, and the game will be fun. So we have this 3 stages, kind of same as before. We have a kind of town, village stage, a forest stage, and a castle stage. And we were like, okay, so which are going to be the best weapons and the best enemies? We brainstormed a lot. Here are examples of some of the things we thought of. And we kind of came to our second playtest, which leads me to a story. So the bear. The bear is a large part of the name of our game. It's one of the most fun weapons in our game, I think, both because of the noises and just because you become a bear. The reason the bear started is Beth had made one of the sprites for the first player, and Mike was like, so I had this great idea. The second player should be a bear. And we're like, Beth was like, no, the second player can't be a bear. The first player is just a human. Like, that doesn't make any sense. And Mike was like, bear, bear, bear. So I was like, okay, we'll make a weapon that turns you into a bear. And we did that, and it was really cool. But like, it made all the other weapons feel lame. And at that point, you could pick up weapons, and then you just kept them forever. They weren't kind of little power-ups that lasted for a fixed amount of time. So the bear weapon, once you got the bear, you never wanted to get anything else. You could get, like, why would you pick up a little dinky sword or some, like, lame crossbow when you could have become a bear and roar at people and, like, swipe at them? So we were like, okay, we need to come up with other crazy things. You see, this crossbow is not cool. How about if you go into a mecha suit and like hit people with your mighty fire fists? That's awesome. That would be cool. Also, we made the change so that, you know, once you get a power up, it only lasts for a certain amount of time. So you have to keep going and getting more items. You don't just get one, then you're like, okay, this one's cool. I'll just keep this forever. So David's now going to talk a little bit about the different design of the different items and the art and how we got that feel.
Thanks. Hi, I'm David. I was one of the people on the art team, along with a lot of other awesome people. Weiwei and Beth and Daniel were really helpful. And we have like Beth and Weiwei's sprites and things really awesome. And when we kind of came together and decided what's really fun about our game was the bear and the wackiness and the craziness of it, we just decided the entire game needs to be that wacky and crazy. And so we're thinking of we need a new name that portrayed that silliness and that craziness. And we were running late on time. We're like, we seriously need a name. Like, I was making the title screen, and we didn't have a title. So that was really awkward. It's like, we need a name. It's like, it's going to be Magic Mecha Bear Puncher 9000. And that's what we just settled on. We thought it, it was kind of crazy. It sounded like, hey, that sounds awesome. Let's do it. So I personally was working on a lot of the tile sets and the title screen and stuff. And a lot of the feeling of the world and what into that is we want to make sure the player felt some sort of progression as they moved area to area. We could have easily made the entire game one long segment of the first thing. We really thought the work that could go into making the new areas would really be powerful. And then we further decided that we could make the enemies look a little different. We didn't have to make entirely new enemies. We just kind of did some recolorings. And we did make a couple new enemies, like the Goblin Archer Law did, which was really awesome. All of a sudden, you had a ranged battle you had to worry about. But I thought that was a really good transition. It got a little harder. Players kind of felt like they were moving along. Like the transition from day to night, I thought worked pretty well because it gave them the idea of time passing. They've been doing it for a long time. But a lot of the problem that came from that was we had to worry about a lot of new assets. Initially, the first level's assets were sort of done from what we had before the overhaul. But then we went into overhaul mode, and the art team was like, oh my god, we have so much we need to do. We need to do tile sets. We need to make a bunch of enemies. We need to make all that stuff. But I thought that was good. Taught us about the iterative design process and how a lot of times you have to throw stuff out. So I think I'm going to hand it over back to Daniel, right?
So, so now Mike is actually going to talk a bit about Law.
Yeah.
Law's going to talk a bit about how we kept track of everything and got our tasks done.
So, okay, I think this thing is still on. So we use a lot of things because it turns out that there are certain programs that do a really good job at doing one thing, but they can't do everything. So we used GitHub. Well, we used GitHub for our source tracking for the actual code, but we use the issue tracker for handling programming tasks. Like, okay, we need to program a collision detection. Okay, that's going to go in the issue tracker. But if you're not looking at the code, there's no reason for you to look at the issue tracker. So we used Pivotal Tracker, another program for art assets. All the art assets went to the Pivotal Tracker. And that was great in separating tasks, making things more modular. But Pivotal Tracker doesn't show you the time it takes to do things. And we needed more short-term, okay, I'm working on this right now. So we used in order to maintain actual task communication, we used HipChat for corresponding between people. And it's like, okay, I'm working on this. What are you working on? Oh, I'm working on this. Okay, so we had a good idea of what people were doing, who was doing what, and when we could expect things to be done. And we had, in terms of after meetings, because we'd have meetings, we would have Google Docs set up for, okay, we went to it's like meeting notes. We had things we talked about, things that need to get done, things that people should assign themselves towards doing so that we can actually have something done in a suitable amount of time. And just in the background, we had Dropbox for non-coding related files. So all meeting notes, all art assets. Actually, no. Art assets were also done through shared through clips, because we coded this in Java. But most of my files, this PowerPoint, for example, or our high-level design docs were shared on Dropbox so that people could see them, they could edit them, but they weren't in a super secure GitHub vault you had to commit and change. So it made it easier to access and change. And that seemed to work well for us. It's a lot of stuff to have to think about and deal with. So you can't just focus on one certain program at a time. You have to be on HipChat and look at your Pivotal Tracker. But I think for managing, what team, 9 people? Our team with 9 people. It was almost necessary, I would say. So I'm really glad that we decided to use all these different programs. Glad they actually exist. I don't know. I feel like it's important that they exist in the first place, so that we actually had access to them easily without worrying about. We just said, okay, we're going to use this program, and it's going to be done, and it was all fine. So.
Yeah. Okay. So yeah. So in conclusion, I think basically we. Starting with the bear, we kind of had our game, and we were like, okay, we're going to have a kind of crazy run around, get random power-ups game. And we just kind of took that idea and we rolled with it. And I think we
not bad for
succeeded. Yeah.
Yeah, not bad for what happened.
Yeah. Yeah, considering we kind of started over halfway through, almost. Yeah, we're done.
Oh, yeah. So, I mean, I guess things in the background that it's good to think about. I think, I don't know if it's important you know it, but when you're coding something, big projects, and you're 9 people, schedules are important to deal with. Not everyone is free at every time, especially at MIT when everyone's taking like 5 classes. Well, sorry. 5 classes is usually the minimum. And you know, every class expects you to do 18 hours of work per week. And so it's pretty ridiculous. On top of that, our artists, both of our artists' computers failed at different times. And so it'd be like, oh, we're expecting this huge, big, awesome creature you can fight and do stuff. Oh, well, the artist's computer failed, so we can't do that anymore. Oh, we're just going to scope it down. Like we couldn't focus on it anymore. Time has been wasted. We need to focus on more important things. Not that that wasn't important, but if we were to backtrack at every step, we would have never been done. We probably would have never done the overhaul in the first place. Yeah. So it's really important to think about these things. They can happen. And if they do happen, you shouldn't panic about it. You should actually just move on, scope down, and figure out what you can salvage, because not everything is as perfect as you expect it to be in your mind. So.
Okay. Yeah. Are there any questions, I guess?
What happened to saving the princess? I remember seeing that like a week ago.
Yeah, so the plot for our game. We initially we were like, okay, like it's kind of a trope where you're like a hero and you go and you try and win the princess or something. So one of our ideas was like, okay, you go, the princess will be in the castle, and the player with the most points will win the princess. But we felt like, I don't know, that was like kind of tired. We were like, why, like, plus we didn't want to have to explain that all at the beginning. We were just like, let's just cut that out. There's monsters, you have to go kill them. And like, yeah.
We weren't really doing the tropes anymore, so the princess didn't make a lot of sense. And I don't know, I think we just felt, I think we just felt that it felt a little awkward, antiquated, yeah.
It's too done. Any other questions?
Okay. Thank you.
Test. Can you guys hear me? Can you guys hear me fine? Okay, sounds like it's working.
You hear this one. Okay.
Yeah.
Hi, we're the Mouse versus Mole team. I'm Kai.
I'm Liz.
And we'll be presenting on behalf of our teammates, Nathan, Tommy, and Alan, and Alex Goins, who is unfortunately not here with us today. So, what's up? All right. The game that we've made actually was based on the concept of competitive mining. Essentially, we wanted to make a game where 2 players could go head-to-head on a 2D destructible environment and basically try to outsmart each other and kill them by knocking them into environment traps, with the use of the power-ups here, which are rocket boots and our bazooka. So for the next slide is going to be a screenshot of the game we currently have. As you can see, the mole character is currently trying to kill the mouse character over with the bazooka. So, let's see. Essentially, I'm going to talk a little bit first about how we got from the 2 words competitive mining to the current game, and then I'll pass the microphone over to Liz to talk about how our project development worked. Essentially, we started this game working on this game from the start of the semester, and it went through 3 iterations before becoming what it is now. Version 0.1 was our paper prototype, which was basically a grid of blocks in which two players had to move across the grid to reach the other side, and that was the goal of the gameplay. The other goal was to kill the other player. One player could kill the other player by breaking blocks out from under them and dropping them 4 squares. We wanted to see if this would lead to interesting player interaction, and it did, but not enough. Players kept trying to rush across the stage too quickly without interacting, and that was kind of boring. So for the next iteration, we wanted to make the game more fast-paced, hopefully with more interaction. And this is our first digital prototype, version 1.0. Essentially, you can see here the grid-based stage is still the same. You have 2 players on the left bottom of the stage. And the goal of this game was no longer to get to the other side, whichever the other side was, but to collect as many power-ups as you feasibly could, as represented by the stars that you can see on the grid. We were hoping that the race to get power-ups would force players to compete with each other to race towards power-ups and hopefully kill each other a lot more. Unfortunately, this also didn't happen because players kept running to their side of the board, collecting all their power-ups and staying the hell away from each other until the stage broke off and they died. So that wasn't too fun either. And as a result of that iteration, we decided for our final version, for this version, that we would force players to interact. We would take out any other goal other than players kill each other. And to facilitate this, we would add in power-ups. As I've mentioned before, we had a bazooka, we had rocket boots, and we had a few other ones. Essentially, this was to make sure that players had to come up with interesting strategies to kill each other, to interact, and to essentially compete. We made this more interesting by randomizing level generation, by giving more terrain choices, and to make players be able to play multiple rounds against each other. So this is one version of the concept art, the first concept art we had for version 2.0. This was actually the version that we thought we would be doing networking on, in which we could have players play across the internet on the same stage with multiple players. You could see only your own screen and your own player and your own power-ups here, but there would be other players all on the same stage trying to kill you, and hopefully be the last person standing. Unfortunately, once we realized that networking was way too much of a hassle to get done in 6 weeks, we decided to move on to 2 players at the same computer, and this is a version of what that would have looked like in prototype format. So, without further ado, I'll pass the stage over to Liz to talk about how our project development worked.
Sure. So in terms of how our project progressed over the term, it initially started with a group of 2 people working on a paper prototype, and then they expanded over to, I think, 5 people working on a small digital prototype. And then finally, we added a 6th person, and we ended up at our final team size. We're the smallest team in the class with 6 people. Kai worked on design and art. I worked on project management and on code reviews and general wrangling. And then we had Ellen working on the sound and on the dynamic music generation. The music in the levels is custom generated in terms of having the soundtrack depend upon what's going on in the game. And then lastly, we have 3 people who worked on the core gameplay, which would namely be Nathan, Alex, and Tommy. So how did we actually make this work? Well, we met 3 times a week, usually for about half an hour each time, and we basically kept it really simple. We went over the high priority bugs, we checked on the status of the things people were doing, but we spent most of the time really talking about open design questions that we had. Contentious things like, should we have the stage fall away from the users? How can we convey that there's a pit of death rising up towards the users? So virtually all of these kinds of deep design questions we decided entirely by consensus with everyone involved so that everyone was on the exact same page. This worked because our team was so small. And then smaller things we ended up deciding via email or via updating the issue tracker, where it was just something minor that a couple of people could get agreement on quickly. So over the course of our project, we had over 200 bugs that we created, and we thankfully closed all of them about 2 days before the project was due. So we started off with a big list sorted from priority 0 must be done tomorrow or the day after bugs, all the way down to wish list priority 4 bugs that we thought we'd never get to. And as we finished bugs, we'd go and promote a few more bugs to be more important, and we just ticked things off and off and off until everything was done. So one of the things that we did was we didn't pair program for the most part. Everyone worked on the coding or on the art or on the music independently, and then we used a check-in system to have every single line of code reviewed by someone else on the team before it went in. So this meant that we had at least one person who was, at least 2 people who were familiar with each piece of code. The one exception was when we did the big port from one game engine to another, we worked together as the programming team on that because we wanted everyone to be familiar with the base state of the code once it had been ported over. So this is a picture of our issue tracker. Obviously, you can see that we've got code reviews going back and forth, lots and lots of comments, and a bunch of sorted priority things that we thought we needed to get done. So we basically assigned things based on who was available, who had the most expertise at a specific thing, and it worked out fairly well. We spread the load pretty evenly, and nobody felt particularly overloaded. We didn't intend originally to say, you are going to be responsible for the bazooka feature from the beginning of the game to the end of the game. Instead, it kind of organically developed that someone would start working on the bazooka, and then if there was a bug with the bazooka, they would probably get the bug unless they were super busy. So one important thing that we did was we started off using GameQuery, which was a JavaScript-based engine similar to jQuery. And it was OK, but it was not great. It did not support camera controls. It did not support animations as fully as we would like. So we ended up switching over to Crafty as our game engine for version 2.0. And that also helped a lot with performance. But we'll get into performance a little bit later. So as I mentioned, we did peer review on all of our code. And initially, it was a little bit contentious. We had some disagreements over coding style. We had some disagreements over how nitty-gritty we should get. And eventually, we ended up sorting those issues out. And we ended up finding small bugs, saying, here's a bug. OK, I'll fix it quickly. And then we got it checked in, and everything was happy. So back to Kai for the conclusions.
So we definitely learned a lot from the course of working on this game. Some of it bad, actually a lot of it good. But we'll talk about the bad things first. So I mentioned networking earlier when I was talking about the prototypes of our game. And the networking we had wanted to implement because it would be a lot easier for one player to just have the entire keyboard to himself and play. But after a while, we realized that, well, networking would add so much extra overhead time to every other feature we wanted to implement, testing it, making sure there were no bugs with parallel things. It was too much of a hassle. So we scrapped networking. But when we scrapped networking, something else came up, and that something was keyboard lockout. Because now that we had two players trying to actively hit buttons on the same keyboard, most keyboards can't handle that many key presses at the same time without one key interfering with some other key on the same area of the keyboard. So that led to us having some really weird and interesting bugs where players could effectively prevent the other player from jumping or shooting their bazooka just by holding down all their keys at once or trolling. I mean, and we didn't want players to settle arguments by punching each other. So we had to do a lot of key tweaking, controls tweaking for that to work out. And as a result of that, we had to cut out 2 of the power-ups that we had originally wanted to do just because we didn't have enough keys to be able to select them easily enough. That was one trade-off we had to make because of mechanical issues. The other one was that JavaScript, while really good for making games easily accessible on all platforms, is not very effective as a processing-heavy game engine. Our game was really slow for a lot of its life cycle just because of loading all of the blocks on the screen, making everything destructible, and we had to write a lot of optimization code to handle that sort of thing. So those were the bad parts of the project. But I think the good parts outweighed those. For one, our team, we basically started working almost from the start of the semester. Our team worked together really well. Even with the personality conflicts, that got resolved quickly. We figured out who had the best skills for what type of thing on the project, and we could assign tasks quickly and easily without resorting to more rigid project management things like scrums or sprints or what have you. We also made a decision to not include way too many features in our game so that we didn't have to go through the cold crunch or death march, as some people would know it, of staying up multiple all-nighters trying to finish features before some deadline or other.
Not a single one of us worked over Thanksgiving, for instance. We decided we wanted to set that time aside, and we did.
Yep. Yeah, that was fun. And we always had a working version of the code, which made everyone happy because it meant we could always have something to turn in. And we tested all of our code thoroughly with code reviews so that nothing was ever inescapably broken. So the next step for our game, I'll let Liz.
Sure. So what's going to happen next with our game is we're going to pretty much immediately make the current state of development available as a free-to-play online game. It's available off of our GitHub site. And it runs on all platforms. It performs best with Chrome, also works OK in Firefox. And to our surprise, it works in Internet Explorer 10, although sound doesn't work because OGG is broken in Internet Explorer 10. So our code, we are intending to maintain the current version at least as open source. It is MIT licensed as far as the code goes, and our media is going to be Creative Commons non-commercial licensed. And further development is kind of up in the air. If you send us a pull request, we'll probably respond to it. We're not sure whether we want to continue development on the project though. So with that, I think we're going to do a gameplay demo and play best of 5 or best of 7 or whatever our intrepid team members feel like doing. Is the keyboard working now?
Yeah, it should be.
OK. So first, let's take a quick moment to look at the controls. So as you can see, the players are moving left and right and digging up and jumping. And there's a double jump that activates the rocket boots. And there's a hold and aim in order to activate the bazooka. So with that, let's go ahead and get started. Do we have the sound working? OK, so let's see. Over on the right-hand side, the mouse is using the bazooka in order to break large chunks in order to get up more quickly. And it's activating rocket boots in order to traverse up through the vertical gap that's been created. Uh-oh, uh-oh, uh-oh. Oh, so close, so close, so close. Does he have enough boost left? Yes, he does. Excellent. Meanwhile, on the left-hand side, the mole is currently attempting to collect as many power-ups as he can. And now they're starting to shoot at each other. Oh! And now the mole makes it to the top, and the mouse is left to struggle to try to reach the top before the lava gets blown up. Now, as you see there, the bazooka can be used as a defensive weapon as well in order to blast yourself up and get out of a trap where you wouldn't otherwise have rocket boots. Uh-oh. Things are not looking so good for the mouse there. Not looking so good for the mouse at all, except for the mole has run out of ammo. And now let's see. I would say that the mole is in the better position right now because the lava is all the way at the top, and the mole has many more rocket boot charges. All right, round 2. So you can look over on the left and the right to see what keys are being pressed by the players. So that way, if you're not standing behind them, seeing what they're doing, you can still get an idea of what they're doing. Let's see what's going on here. We have the mouse who is collecting a few of the red power-ups in order to power the jetpack. On the left-hand side, the mole is going and digging the conventional way, and meanwhile, the mouse is using the bazooka ammo in order to dig faster up to the top. And soon we'll have the 2 players meeting in the middle, and uh-oh. The mouse's maneuver backfires, and he finds himself, oh. Mouse was briefly out of ammo, but they now both have ammo, and they're now going to start shooting at each other. Uh-oh, uh-oh. So close, so close. The mouse is in trouble. So is the mole. Do they have enough ammo to make it? That is the question. The mouse is saving his ammo, and the mole nearly hits the mouse, but doesn't succeed. What will happen? Now it's a race to run out the rocket boot charges. And the mole loses. This time they're slugging it out.
Oh, shoot.
Oh, that was a blunder.
Oh, I got it. Lost it.
So let's play best of 5. Let's play best of 5. So 2 more games left. Oh, wow. So close to it, landing a direct hit. So if the mouse wins this one, he'll win the best of 5. Oh. Uh-oh, the mouse is out of charges. The mouse is out of ammo.
No.
Okay, the mole has... Oh, nice save. Very nice save. And this time, the mouse is going to win, barring a sudden change in circumstances. And good game, mouse. So that is mouse versus mole. Are there any questions? Let's go ahead and close that.
Can you put the URL up?
Yes, I can. Let's exit full screen and we can show. So it is at my GitHub /mouse versus mole. linsleywright.github.com/mouse-vs-mole.
Yes, so I just want to ask if you feel that the lava level was rising too quickly.
We have played around with the numbers. We think the current iteration might be a little quick, but it seems playable.
Most of our earlier playtests had the lava slower than this, and we slowly inched it up until players stopped saying that they didn't even realize the lava was rising.
Is there any dominant strategy other than by that I mean is there a counter strategy to always just going to the top with as much rocket power as you manage and then floating until the end?
We were playing relatively passively early. You can try to play a more deny style, like chase them and blow up their power-ups as they get close to them, or try to last hit their power-ups, because it's the person who does the last hit on the power-up that gets it.
Yeah, we did a lot of playtesting before like this big presentation even started, and we actually started getting more aggressive in the later games after we had gotten more used to everything again. Like, it seems like really early you get killed by the lava before you can dig two up, and then you start getting used to it a little, and then you start just going straight to the top with as many power-ups as you can find. And then after a while, you start trying to actually kill your opponent before they can even get to the top.
More aggressive strategies seem to be more mechanically difficult to execute because your aim has to be better.
But if done right, they're more guaranteeable.
Yeah.
Yeah, the anti-turtling strategy is to shoot your opponent out of the sky.
Yeah, it's not like there isn't one meta that we have to follow. It just, those games went that way. They don't have to go that way.
What were some of the other power-ups, and how did they change your game in your previous iterations?
Microphone.
So other power-ups we actually had before were a grappling hook was meant to help you navigate the level a lot more quickly, because from the first iterations, people were complaining about not being able to jump to the top of the stage enough. We decided that the rocket boots got rid of that particular need, so that was left out. Another power-up that we threw around but never actually implemented was the power-up that you could leave a trail of blocks behind you as you ran around the stage. This was meant to be a sort of blockade mechanism. Maybe these blocks were meant to be semi-indestructible so that your opponent had to take a long time to get through them. And maybe they would be blocking off his access to power-ups that he needed, which would, I guess, have also prevented the jump to top of stage, rocket boot forever thing. But yeah, those were some of the ideas for power-ups that we had.
Also, we had the drill in which you could place an item that would go and immediately tunnel directly down to the bottom. And if your opponent happened to be standing in the path of that, then they would also fall down to the bottom because all of the blocks would be cut out from under them. But we ended up playtesting and finding that the rocket boots plus the bazooka were enough in order to ensure good player interaction, and we kind of didn't have to go to the additional complexity.
In particular, the drill was not implemented because we found through playtesting that it was actually best to start people as low as possible, such that if someone even got high enough for the drill to be useful, they would already have too distinctive an advantage against the other player.
How are the levels created? Are they the same? Like you pay 3 rounds, or is it?
They were different. It's generated before every.
Wow,
Yeah, Tommy can explain how the levels works.
Yeah, there's like caves and there's like tunnels between them, and it's just randomly generated.
Like,
So
there's basically a hole punching function and like a tunnel to next hole function, and like it's randomly generated, but with a base as like 2 holes around the player's starting locations. So we also made sure that you can't be spawned immediately over a pit of lava, but besides that, it's random all over the place.
yeah, it's not the same stage every time.
So, looking at the control scheme, where you press down the button and then you release to fire, that looks like you would have a lot of ghosting issues. One of the design aspects we had to change over game was the charging slingshot, because players holding down 2 keys at the same time on the keyboard would introduce terrible ghosting. It was impossible to aim. So how do you deal with this problem when 2 people are playing on the same computer? Do you have some way around this, or do you just use a better keyboard?
So we actually switched to this control scheme because of the ghosting issue. Before this, we had been throwing around ideas such as you have 2 dedicated keys to aim the bazooka, but like then we switched to only having 1 key for the bazooka, which is reduce the ghosting issues. And we can also position that 1 key so that we minimize like interference. Like we chose C and space because they were like the least likely to cause issues. So even though you're holding it down more, we found that it still creates fewer issues.
The other change that we made was we made it so that if players were previously holding down the jump key in order to repeatedly get jumps, but we made it so that if you hold down the jump key, you only get 1 jump out of it. You have to tap it repeatedly. So that.
We were able to change that back.
Oh, we changed that back?
Yeah,
okay.
we were able to change that back.
Let's see that.
Because we selected the arrow keys instead of, we originally had it as IJKL and N was player 2's fire button, but because of the ghosting issues that we came up with from that, we switched to the arrow keys in space for player 2, and I don't think it ghosts on any of our keyboards if people are not intentionally mashing down more keys than their players can enact actions at once.
Yeah, the arrow keys are relatively isolated,
like
for most keyboards.
I think you can cause ghosting if you just hold down like WASD and C at once. You may be able to stop your player 2 from doing anything, but that's intentionally being a jerk. So,
and that's resolved by punching the person next to you.
We actually had issues running 2 keys pressed down at the same time. 2 special keys that were part of our control scheme would disable 1 player's jump, so it was very, very annoying. But I'm glad you guys worked around that.
Yeah.
Okay. Well, that's the last presentation of the day, so give all the teams a big hand. This mic works, right? Yeah. So this is the end. I'm not sure if I still have snacks outside. If we do, you are definitely welcome to them. Thanks to all of the teams. You're all great for a great semester. Hope you can all get some rest now. And if anybody does want me to share any URLs on where to get the games if you want the public to play these games, send them to me. I'll put them on the MIT Game Lab website, and that way the public can find them a little bit easier, even if you want to link them to your GitHub page or something. So again, thank you for everybody for coming, and yeah, this was CMS 611 6073 creating video games. Bye bye.